Hello everyone, thank you very much for joining us today for the second in this series of 3 webinars brought to you by the organisers of the Sustainable Industrial Manufacturing Events, or SIM as they are better known. My name is Nadine Bloxham and I will be your host today to welcome the founder of Circularise, Mesbah Sabur, to enlighten us all on how blockchain can complement MassBalancer certification. Now, Mesbah will explain different chain of custody models and discuss the ins and outs of mass balancing. Listeners will learn about the different challenges with mass balancing and about the opportunity of using blockchain within supply chain traceability. It's quite hard to say. Blockchain technology plays a key role in providing an immutable record of chain of custody, thus bolstering mass balance certifications. And we're really pleased to have Circularise here with us today because they have recently launched a new product, MassBalancer. This ISCC PLUS mass balance bookkeeping automation software permits users to manage balance for all sites, automate mass balance reporting, and also gain an in-depth insight. So in this webinar today, you will learn how to set up a scalable bookkeeping process without complicated spreadsheets by means of this software solution. So I'm really excited to get going on this. And to any attendees who are new to this platform, please note that you can ask open questions and add in points for discussion in the chat box that you can see on your screen. Our speaker will monitor these questions as we go along, and we may answer them at the time if it's fitting within the discussion. Otherwise, there'll be time for a dedicated Q&A session at the end of the presentation. A specific Q&A box will also appear on your screen as we begin, and you're able to ask more private questions directly to our speaker through this box. Please also note that this session is being recorded, and we will add the link into the chat box for you to download the video after we've concluded today. So that just leaves me to introduce our speaker, who, as I mentioned, is the founder of Circularise, Mesbah Sabur. I'll hand over the microphone to him now and look forward to the presentation. Thank you.
All right, well, thank you. And I'm very much looking forward to this session today, and I hope to make it as interactive as possible. So let me see, the slides are a bit strange, at least on my side. The background appears to be white. Is this only on my side, or is everybody having a white text on a white background, which is unreadable? Yeah, the background should be dark, because otherwise, let me see, go through the presentation. Yeah, a lot of it was unreadable. All right. All right. I see that. It's okay for the viewers. All right, then at least you guys can see the right slides. Appears to be a slight issue on my side, but that's okay. I know the slides. So let me just start with a quick intro. So Circularise is a company from the Netherlands. We are bringing traceability and transparency to global supply chains. And what we are aiming is to make sure that companies can share information about their products and the sustainability thereof in order to make sure that the final components and products in the hands of consumers have a story to tell. So we know where products come from, how they were manufactured, and what kind of a sustainability history these products have. And obviously, when you talk about transparency, etc., you have to talk about how do you get this information from upstream raw materials all the way to final products and components. And this is usually done using certain traceability models. So today, I'm very happy to talk about different methodologies, including mass balancing, how they are comparing with each other, but also how blockchain, which is an emerging technology, especially in the field of sustainability and supply chain, being applied more and more in the last couple of years, can play a huge role in making sure that that information travels correctly from one stage to another. I'm just monitoring the chat here and see that a few people are indeed reporting a white background, which makes it pretty unreadable. Perhaps I can share the presentation on my side. Let me see if I can pull it up from my computer and see if that's going to improve. It's loading up now. So how does this look like, guys? Is this better? All right, amazing. Perfect. All right, now that we have the slides in place, let's just go over the agenda today. So yeah, this is me. Kind of introduced myself already. So we're going to talk today about what traceability is in general, what kind of a chain of custody models we have, and what is particular so interesting about mass balancing. Somebody's touching the slides. And I'm not sure who's controlling the slides here, but I'm not doing anything here. I don't know if the organization and the host can help me out here, but it appears that somebody's controlling the slides. All right. So we're going to talk about the different traceability models, chain of custody, and in particular mass balancing. We'll also talk about some of the challenges we've seen, and then obviously some of the opportunities within specifically the blockchain-based mass balancing as well. So kind of moving on to the different models within chain of custody. First of all, let's define what a chain of custody means. It's essentially, for those that aren't aware or familiar with this, it's understanding the sequence of ownership of some good, something that you can own, for example, a raw material. And the sequence of ownership kind of shifts through the supply chain from one person's custodian ownership to another in the supply chain. And this is pretty much used throughout the supply chain as the basis for various claims, in particular with mass balancing and in some of the industries that we're very active in like the petrochemical space. We're using frameworks around mass balancing from different schemes such as IACC and RSB and RedCert and what have you, to use that framework to come up with a chain of custody and eventually some sort of a statement based on the as the definition says, the sequence of ownership and control of the material over time. And the goal is to be able to really validate claims about products and have some sort of a standard that we all use in order to make sure that some claims are backed up by the right data. When it comes to the different functions, you can translate that into kind of use cases, like why would you want to do this and what's kind of the end goal that you can reach by having a chain of custody. Obviously, it's improving transparency in the supply chain, but it can be looked at from different lenses depending on who you are and what you might find interesting. So you can use that information in, for example, things like identifying the origin of the final product from the original feedstock. You can understand and make sure that you link the sustainability practices with actual products at the end of the day, specifically if they're not really easily identified. For example, like chemical recycling. If you have chemical recycling as one of the upstream processes, it's nearly impossible to tell from the final product that happens. So that chain of custody is going to be more and more important in order to attach that history and that value to the final product and have that claim being validated. More and more, we also see that as a basis for lifecycle analysis. So you could use that information to then compile essentially your lifecycle inventory and take it from there by having that chain of custody attached to it. Then this is also where the different chain of custody models become really interesting, because the world of LCA and carbon emissions and greenhouse gas protocol and the world of mass balancing and different chain of custody models still needs to kind of merge. So we know, how do you attribute something that is on a mass balance basis sustainable in your lifecycle inventory, and how do you calculate that, and how do you bring these things together? So there's a lot of discussions going on right there to make sure these kind of concepts talk well with each other and play well. All right, just kind of moving on to an overview of the different chain of custody models. You can view them from left to right, as the main difference being that the connection between the physical product and the sustainable claim is decreasing over time as you go from models on the left of this chart to models on the right. So if you talk about the best way of doing a chain of custody model where the product and the claim are one-on-one connected to each other, it would be an identity preserved model where the identity of the physical product is preserved over time in the chain of custody. And when you go to the right, you kind of decrease that over time. And mass balancing sits somewhere in the middle, where on the kind of extreme end, you on the right, you have a certificate trading, where there's physically like no real connection between your claim around sustainability and the actual product that you attach it to. So let's kind of go over some of these examples so we have a better understanding of what they mean. So if you talk about physical, identity preservation, you really try to decouple the different streams from each other. So if you have, for example, a manufacturing plant where you treat and manufacture sustainable grades of products and non-sustainable ones, you have to segregate everything. You have the non-certified products treated in a separate way, and the documentation thereof is treated separately. Everything that is certified is treated separately, and within the products that are certified, everything is also separated, usually on a batch-by-batch level, right? So you can really tell everything from each other. Every single batch, every single sustainable as well as non-sustainable batch carries its own identity and is traced accordingly. The difference between that, which is essentially a perfect model where every single claim is backed by the exact physical material and there's like no mixing going on whatsoever, and segregation, is that you still do treat the certified products separately from the non-certified products. However, the difference is that within the certified side, you are essentially mixing the volumes. So you might have a manufacturing plant where you have sustainable feedstock as well as like a fossil-based feedstock that you're treating. If you're doing segregation, then you're treating them separately, but you're not keeping track of the certified side on an individual batch-by-batch level. There, you're still mixing them, right? So you wouldn't know at the end which exact sustainable feedstock ended up in which exact final product, because you still mix them, but you know that the sustainable feedstock never was mixed with the non-sustainable feedstock. That's the main difference. And then going to mass balancing, there's even more overlap because what you're then creating in mass balancing is that essentially you accept and allow the mixing of non-certified with certified material. So it's not segregated at all. You have like one manufacturing plant where you buy both the sustainable material as well as non-sustainable material. You're allowed to mix them. However, as the name suggests, you cannot do like kind of claim more than you have than what you have purchased on the incoming side. So there's different models to do that. You can do it volume based, on mass based, or percentage based by fixing these materials and allocating them. But bottom line, you cannot overclaim based on how much you've bought. But the big difference is because you're mixing these materials, these certified sustainable materials with non-certified non-sustainable materials, is there's no real guarantee that the certified content ends up in the actual final product, right? So that's a real big difference in terms of how you're allowed to allocate sustainability claims in mass balancing as opposed to segregation and additive preservation. Mixing is allowed, which creates a lot of opportunities, because if you have a huge plant with a very high amount of throughput, a lot of volume, and you only have a small fraction of sustainable material that you're buying initially, being able to mix that and allocate it accordingly allows for much greater flexibility in terms of the final claims you're making, without having to immediately switch the whole manufacturing plant over to fully sustainable and high volume production of sustainable materials. So it's often considered as a transitional technology that allows companies to move away over time, move away from non-sustainable materials and use mass balancing as an intermediate technology up until a point where economically it makes sense to introduce segregation or identity preservation models. But as you can imagine, that also comes with quite a huge investment in terms of changing your operations or how your plant works in terms of the different products that it's dealing with. Looking at specifically the mass balance model, you can have different gradations, like how you're mass balancing on individual batches or on site level, or even on a group level where you balance it out under the same legal entity. Oftentimes we see the site level mass balancing being popular, where on a physical location, let's say a geographic boundary of a physical manufacturing site. So that's where we kind of draw a boundary, and everything that comes into that geographic bounded site, you kind of are allowed to mix within that same manufacturing site. So the non-stable and stable materials are getting mixed in the physical process. However, on the credit or the claim level, you can separately make sure you account really well for how much you've bought exactly and how much you're then claiming on the other end when you're selling your products. And the kind of the far left chain of custody model is around certificate trading, where I think most people have experienced this in one way or another. It's particularly getting popular with carbon offsetting, where essentially you buy some credits that were attributed to some action in the world, for example, planting trees, and then you're using that act to make some other thing that is totally decoupled from it be labeled as sustainable. For example, if you're taking a flight, then you could say, all right, I'm offsetting that with some carbon offsetting models around planting trees, which obviously doesn't change the flight. So the physical product and where the claim is living at is totally decoupled from the actual claim of the sustainability attribute. So when we go in particularly to the challenges of mass balancing, because that's the topic of today, you see that there are kind of three high-level themes of challenges that kind of also pose opportunities. The first one being that the manual process of booking in these mass balance materials, making sure that the sustainable materials are in balance essentially with everything that is claimed on the final end of the final products is correctly done, is pretty fraud and error prone, because oftentimes how this happens is with the semi-manual process, where companies often buy these sustainable materials. They get a PDF document by email that they need to process internally, book them into some sort of an inventory, often based on Excel sheets and manual processes, and then allocate that accordingly. And as you can imagine, not only poses that issues around scalability and potential mistakes that you can make there, but also it introduces the potential for fraudulent actors to misuse that system. And the more we can kind of take that away, the better. I'm not kind of advocating that all of that can be fully solved by using blockchain technology, but there are definitely certain elements where if you would use blockchains in a correct way, you could automate a lot of that verification of correctness, meaning the verification of the correctness of the mass balance bookkeeping, essentially, in the inventories and the allocation of the different materials that you've never double spent, for example. The other challenge is around the complexities in supply chains. As you can imagine, there is a huge amount of different materials that go into final products. Imagine automotive products or some more complex electronics. And to be able to do mass balancing or any kind of traceability model really at scale, it really introduces a huge amount of complexities when you're thinking of end-to-end traceability for final products that have hundreds or sometimes thousands of different suppliers coming from all kinds of different materials and industries. And doing all of that in a blockchain way poses a nice opportunity, because if you're using a public infrastructure like a Ethereum or an open source blockchain that anybody can refer to and verify correctness of some sort of a statement or a chain of custody model, it opens up for the door for an open infrastructure where different markets, whether that's plastics or metals or textiles, can use their own infrastructure, their own solutions, whether that's like built in-house built solutions or commercial solutions that they buy from vendors. But they're all referring to that same public infrastructure backed up by blockchain technology to verify the correctness of certain statements and not depend on manual verification or inter-solution trust, essentially, that these data points are correct and not handled in a wrong way. Because the main thing that we see is that sustainability is specifically in certain domains in extremely high demand. Having sustainable materials often comes with a premium. So therefore, there's an economic incentive to potentially make fraudulent or wrong statements. Therefore, the more we can trust or essentially outsource trust through technology, the better the infrastructure will be, the more robust our claims will be, and the more trust we can gather from external parties, whether that's governments or consumers. And last but not least is obviously there's also a time element and an automation element there. That's not necessarily attributed to blockchain, but in general, any kind of digital automation software can bring a huge amount of efficiencies in just the fact that it's machine readable and automated information sharing, as opposed to manual Excel and email-based communication. All right, so let me kind of break these things down one by one. So if you look at the potential for error and fraud, so the way a blockchain can really step into this verification of correctness of data is, imagine you have three different sites, right? So this table kind of represents three snapshots of a ledger, of a balance, essentially. So imagine you have site A, site B, and site C. Maybe these are three different companies, and they're doing, handling some sort of a sustainable feedstock. And these companies also have some internal trade between them going on, where they ship some material from one company to another. And obviously, doing mass balancing, it's very important that they keep track of how much they've bought, how much they've allocated and sold to their customers. So on the left, you see the account balance of the three companies, ABC, being 500, 300, and 600. So that's like on day one. On day two, that's there's a slight change. B decreases the balance by 50, and A increases the balance by 50. So there's a transfer essentially of 50 credits from account A to account B. Then the last snapshot, there is another transfer where account A loses 100 credits and account C gains 100 credits. So there's a transfer from A to C. This is essentially a way to do bookkeeping where every individual company has its own balance, and over time you see changes in balances as the companies are buying materials and selling materials, and they could, you could obviously introduce more complex logic here to also keep into account things like manufacturing yields, like conversion factors, etc. But in a very high level, this is what's happening in mass balancing. However, there is no real connection between the balances of the different accounts. And within a blockchain, the way, for example, technologies like Bitcoin work is very, very similar, if not almost identical, where different accounts can have a balance. And if you share a Bitcoin with a friend, your balance on the blockchain, if you just literally would look at the blockchain and read it, would be decreased by that amount, and your friend's balance would be increased by that amount. And the way this works, and the reason why we can trust these things, that people can just create balance out of thin air or spend more than they actually hold in their accounts, is by running all of these balances simultaneously on many different computers around the world. So it's not that there's just like one single database where these balances are. The way blockchains work is that specifically for public, like blockchains like Ethereum, anybody can run a node. Anybody can run a copy of that chain and verify that nobody transacted more than that they held in their account, right? So you can put as part of the rules of the system, and by having a game theoretical mechanism in which each individual party who is running that blockchain can keep others in check by having incentives to play well, you can create a network that is kind of self-controlling, and it's not relying on trust of a single entity. Rather, it's relying on the game theoretical incentives of a full network. Therefore, if you want to manipulate this network, whatever you want to do would take a huge amount of effort in terms of convincing that network, or trying to come up with a different methodology or different incentive that will overtake the system. So in practice, this means that these networks tend to run on their own, with their own essentially logic that companies can. Can you guys hear me? I see some issues on my screen with my microphone. Oh, great. All right. So in a nutshell, this is how these companies are, so how these blockchains are run, by having all kinds of different balances running around the whole area. The thing that really made it interesting is that smart contracts were introduced with Ethereum, which meant that we went from having essentially very simple balances on Bitcoin, where you have a few amount of credits and you can share that, to doing a similar type of logic where you have a certain balance and you can play around with that, be also possible to run on arbitrary code. So with smart contracts, we said, let's not just run these balances, which is pretty straightforward and simple, but let's allow anybody to run any kind of arbitrary code. And everybody checks each other's code, whether that code executed in the same way. So once we agree upon the smart contract, it's okay, this is essentially the rules of our methodology of our game. Everybody can check each other, and there is a game theoretical incentive mechanism that people don't cheat the system. So in most blockchains, this means running the system in a correct fashion means you earn fees, and players who are using the system are paying those fees. Those who are running the system will be collecting the fees, and therefore economically incentivized to run the system in the right way. If they don't run the system in the right way, or they try to like manipulate the data and play outside of the rules of the smart contract that was already pre-agreed upon with all parties, they have an economic disadvantage because they will be penalized, and they might pay fees, for example, in proof of stake, where they stake their money. And if they will do something wrong, they lose their money. So what does this actually bring? How do we translate this then back to what's actually happening in chain of custody models and particular mass balancing? So what you can do with this is you can then use this powerful, essentially basic principle of smart contracts and try to build logic around principles that we would otherwise need to manually audit, right? So, for example, in mass balancing, you can audit, and you have to audit before you're allowed to get your certificate, whether you have not spent too much, right? So your incoming and your outgoing materials are in balance, and you have applied the conversion factors or the manufacturing yield rates correctly, and that you have only handled certain materials as incoming, outgoing materials according to what you're certified for, and you didn't deal with materials that you are not able to deal with, all that kind of stuff. You could translate that, as opposed to relying on auditors that go to a facility that is getting a mass balance certificate, for example, once a year, and check retrospectively where in the last 12 months that company did a double spend, didn't use materials that were outside of their control, or did not apply the right conversion factors. And these are just examples. You could just kind of add any kind of machine readable logic to this. You can build that into the smart contract, and by virtue of agreeing that those are the rules that we all want to play with, so these are the rules of the mass balance certification, for example, everybody is controlling those rules and making sure that everybody's playing around those rules specifically, and therefore you get a stamp of approval that you've played accordingly by design, as opposed to 1 year after the fact that people kind of look back and an auditor would physically come and check these things. Obviously, this does not mean that everything that an auditor does can be replaced, because an auditor will also do some physical inspection, or they might also look at some stuff in the real world, where they might look at the facility and its capabilities. Obviously, you still need that, but the amount of information that an auditor will also need to verify that can be replaced by a blockchain means that an auditor can actually focus on those things more and more. So it's more of an interplay, where the more we can kind of outsource to a blockchain, the more logic of a system like mass balancing, the more trustworthy it will become over time. But with the caveat that you always need auditors, you always need that first entry of data where a physical audit has happened, a company has been inspected accordingly, but then many of those initial restrictions and boundaries were set in smart contracts. So you can have more like automated ongoing audits as you go, and not rely on like annual audits that might be replaced fully by digital technology. For example, if you look at double spend prevention, so it's a fairly simple concept, and it's really, really hard to prevent this with traditional systems without creating a huge amount of trust. But it's actually kind of built in to the blockchain by design. For example, the notion of double spending, right? So sending 15 credits to your customer by design on a blockchain means you can't send those same 15 credits to another customer, right? You can only spend it once. Whereas if you don't use a basic primitive of a blockchain and the way it operates, you either have to have a central system that everybody trusts, so like a central single authority that we all report to and keeps our balances, or we all kind of trust each other and we do it well, and then once a year an auditor will spot check some of the transactions and make sure we didn't double spend, which is way more prone to error and fraud than just relying on a central public blockchain that we can all verify that nobody double spent any credits in the same way that it happens with Bitcoin. If you send the Bitcoin to somebody else, doing it directly on the blockchain, not using some sort of a central middleman, you can verify, or anybody in that network can verify, that you've actually sent those Bitcoins and that you've lost those Bitcoins in your account. Therefore, you're not allowed to, or you're not able to spend them again. When it comes to, for example, handling different materials in terms of, let's say, IACC certification, you have all kinds of materials that you get certified for, that you're allowed to have as input for your facility. Because remember, this is a mass balance certification on a site level. So every single site gets its own certification, meaning these are the materials that you're allowed to handle as input, and these are the materials that you're allowed to make out of these input materials and manufacture and sell as your output. Once this is set, and this is typically done in an annual initial audit, you could translate that into the blockchain and say, well, this account is only able to receive these materials and manufacture these materials. And by virtue of translating that into a smart contract, that account will always apply to those rules, and they will not be able to receive anything outside of those input materials, nor will they be able to manufacture something that's outside of those initial certification. Well, if they want to change that, of course, they need to go again and do an additional audit. But at least the auditor has peace of mind that they are in control of the input and output materials. And it's not something that they need to retrospectively check against the correctness of it once a year, for example. The other challenge that we initially said outside of the first one, which was around error and fraud, was around the complexities of supply chains. We take a very good look at how some closed and open infrastructure solutions work, specifically around things like email. We see a huge amount of inspiration that we can take there because email works with an open protocol. Even though there are commercial vendors out there like Microsoft's Outlook or Google's Gmail, they are still working together. So you don't need to necessarily have everybody from a given market, whether that's like a supply chain, to use the same solution. They can interoperate because they're working on the basis of the same protocol. They have a single source of truth, essentially, when it comes to how to deal with data, how to receive it, how to send it, and how to read it. Therefore, it becomes pretty much an industry standard. And this is, again, extremely important when it comes to these complex supply chains, where there's sometimes half the periodic table of elements inside the final smartphone, like that. Imagine that supply chain and how complex it is and where all these materials come from. You can't just rely on a closed approach because that will never scale beyond initial smaller environments. You have to have some sort of an open protocol that everybody relates to, and everybody can also verify correctness of certain statements without having that single solution that we all trust or that we all use, and therefore kind of defeat the whole purpose of using decentralized solutions, such as blockchains. For example, how that could look like in this case is that there is a shared public blockchain acting as a single source of truth. And you can have different solution vendors essentially applying or publishing some of their statements on that single source of truth blockchain. And even if you have a supply chain of 10 different parties, like 10 different tiers, some tiers might use vendor A, some tiers might use another vendor, but it doesn't matter because they're all using the same single source of truth. And therefore, if one company uses one solution and they send those data points and those sustainable materials, for example, onward to the other one, the other solution can trust the correctness of that statement and take it forward. And obviously, as you go into the supply chain, it becomes more important because as the final brands and OEMs, you have a huge amount of suppliers in many different industries, and you don't want to put trust in every single solution, and essentially all use the benefit of a single decentralized ledger to be able to verify correctness of some methodologies using smart contracts. And the last point is obviously the fact that it's just very time consuming. Right? Today, doing mass balancing in many industries is not quick. It's not the most fun thing to do. And just by introducing blockchain, you have to, by definition, kind of also introduce automation and digital tools to support that. And therefore, that poses a very natural automation step when it comes to making sure that you deal with these mass balance credits incoming and outgoing. And that's also where we focused on all of these problems with our projects that we released and finalized very recently with these 10 actors, including IACC, which is a leading certification scheme in petrochemicals and sustainable plastics and chemicals. And try to kind of understand how can we introduce a technology like this, because where is the market at today? What are they doing today? How well is the understanding of blockchain and its capabilities, as well as its shortcomings? Yeah, this is essentially where we are right now. I hope the talk today has been a little bit informative for you guys, and we also have a little video that we want to run, which is a summary of essentially this project and a high-level presentation. And yeah, happy to convert to any Q&A that you guys might have.
Our planet is under pressure. Due to increasing consumerism and a linear economy based on take, make, dispose, climate change and resource shortages are soaring. The answer is moving to a circular economy. Together with these pioneering companies, we are driving change towards circularity. But how? Mass balance. Mass balance is a solution to facilitate the shift to gradually replace fossil materials with sustainable alternatives. This is how it works. The mass balance approach allows for the physical mixing of fossil and sustainable materials, while keeping track of the exact quantities. Although the actual quantity of sustainable molecules in a single product cannot be guaranteed, mass balance makes sure that the quantity of overall sustainable materials is directly reflected in the number of end products labeled as sustainable. In this innovative project, Circularise and partner companies worked with the certification scheme ISCC. Let's take a closer look at this example. Using Circularise's traceability software, partners could digitize sustainable materials and certificates and track sustainability credits along the entire value chain. Circularise's software helps companies to automate their bookkeeping process for ISCC PLUS certification. Companies can easily book, allocate, and send sustainability credits. They can generate sustainability declarations in a few clicks, automatically create quarterly reports, and connect to other actors in the value chain. Consumers, on the other hand, can access sustainability data and certifications of the products they buy. With Circularise, they can trust sustainability claims of their favourite brands. Circularity is fundamentally a collective action. With the mass balance approach, we can inspire more companies to shift to sustainable materials and embrace circularity at scale. Do you want to make a real difference? Join us. Visit our website to explore more.
Thank you very much there to Mesbah, and hopefully you were all able to see the video well. It looked really good on my screen, so thank you for sharing that. Now we have had a few questions come in, so I will just have to bring back the screen so that I can see those. But just from my side, one question I just wanted to kind of touch on is, are you seeing any common challenges that your clients are facing when implementing these kind of blockchain technologies? Is there something common at the moment that you would like to just kind of reflect on? Mesbah, I'm hoping you're still there. That was just a question for you. I'm not actually sure if Mesbah, hopefully he's still with us so that we can ask some questions. Otherwise, at the moment, what you can see in the chat is some links towards our next webinars, and also David and Julia have put some great links in there so that you can follow up on anything else after this session. I'm not actually sure if Mesbah is still there for us to answer these questions. So what we might do is send these questions over directly, and then there will be an opportunity to follow up afterwards. Ah, he is still there.
Oh yeah, I got kicked out of my microphone for some reason.
Oh no!
If you can hear me now, I'll be able to answer the questions, no problem.
Oh, fantastic! Yes, I can hear you now. Sorry, I thought you'd run off at a pivotal moment. Okay, yes, we've had some really great questions come in. I did just fire a question at you, but actually let's look at what the audience have asked instead. So one of the first questions is, what are the main differences between the different chain of custody models? So if you can just give a bit of clarification on that, please.
Yeah, so the main difference in a nutshell, without going too much into details, is the connection between physical and the digital claim, right? So the better the chain of custody model, the more the claim is actually talking about that exact physical material up to the final material or the final even molecule. But that's also much more expensive, and in any cases, frankly, economically not possible to implement. As you go to the other side of the spectrum, that claim becomes more and more decoupled from the actual physical material. Doesn't mean that it doesn't do good overall on a worldwide basis. It's just like the more you try to keep the claim and the physical product connected and very well matched, the more expensive it's going to be.
Excellent, thank you. Okay, I can see that the chat box is also lighting up, but I'm just going to go to one of the questions that we had submitted through the Q&A. Now, this one outlines that you mentioned that there is no guarantee that there is any certified content in the final product, but you still claim that the product is bio-based. So this person writes that depending on the added feedstock and balancing, making sure you only make claims on the amount equivalent to added bio-based feedstock. So they're saying that this is great for encouraging industries to be more sustainable, but how do certifiers make sure that consumers do not see this as greenwashing, as their product is technically not fully 100% bio-based since different feedstocks were added? So that's quite a long question. I hope you...
yeah, it's a very good question, because if you don't explain what actually happened in the supply chain very transparently and very clearly, you do risk the possibility of consumers seeing that as greenwashing, or the possibility of some brands and OEMs just misusing those claims and making certain statements that might not be true. So what we now see is a better understanding on both sides of the equation when it comes to what actually mass balancing means and how to then communicate about that, right? So just saying this is a bio-based material would be wrong, technically wrong, but also just would be wrong and like ethically, because it's just not correct, right? So we're now seeing lots of brands and OEMs being able to like experiment with how do you position it better. Like one of the things we see is that you can say it's contributing to bio-based feedstock collection, for example, which is technically a correct statement. And specifically by having these the digital layer using blockchain and making that very, very transparent and as independent as possible, you're actually creating a better story to the user, because telling it in a very easy way to a final consumer and making it a very transparent statement as opposed to a potentially technically wrong statement is actually really helpful and makes consumers also increase their trust towards these brands. But it is a very, very important part because you can easily make statements that might not be true, and it's very hard to explain these concepts without going into too much detail. So that balance is important.
Okay, excellent. Thank you very much. I hope that's answered that question for you there for our listeners. Now, I did start off the Q&A just with a question that I had, which was mainly with regards to what challenges you're seeing that companies are experiencing when implementing blockchain. Are there any kind of common challenges? And also someone's asked in there, which we could tie in with this question, whether there are specific challenges maybe for certain industries, and if you're seeing again any commonalities across industries when implementing these kind of technologies.
There are common challenges. I think one of the most common challenges to get the supply chain aligned. So you need the materials and the component manufacturers and the final brands and OEMs to all kind of come together and not only agree upon the shared value of traceability and transparency, but also agree upon a common methodology and common shared vocabulary, right? So a lot of the challenges are, to be honest, not technical, right? I think a lot of the technical capabilities that you would need are in place, and a lot of it is maturing very rapidly. It's just like a lot of the challenges are around how do you bring parties together and make them see the value and create that network with a shared understanding. And there's some industries that are really reading it and pioneering it, but there's also lots of work being done on the governmental side and regulatory side to make that a more harmonic and standardized way of communicating. So yeah, I would say a lot of the challenges around that, and obviously every sector will have its specific challenges, right? Some sectors have way more challenges when it comes to confidentiality and sharing not too much and making sure that they keep control of who sees what data, etc. Whereas in other areas, the challenges might be much more around operational challenges, where some of the actors in the supply chain might not even have access to the internet or a modern computer. So depending on where you are in the supply chain in the sector, you might find slightly different challenges, definitely.
Okay, thank you very much. I know we are quite tight on time now, but I'm just going to try and run through a couple of these other questions quickly. So one that's come up in the chat box is with regards to how you look at having the risk that if you don't have, sorry, I'll rephrase it again. How do you look at having the risk that you don't have enough people volume on the blockchain with credentials?
The risk of not having enough people volume?
Yes, sorry, that is mentioned in the chat box, so maybe we could get some clarification on that.
Okay.
But for now, we could come on to a couple of other questions that have also been added in. If that is, maybe we could go back directly to that.
Yeah, I would have to understand the context of this question. I'm not sure what is meant here by people volume on the blockchain.
Okay, I think Brett's actually typing, so maybe we'll get a bit more clarification. So I'll look back in the chat box in a second. For now, one of the other questions that we had coming in was, while piloting this tool, what kind of data generation obstacles did you identify along the value chains, and what could help to resolve this, in your opinion?
It kind of comes down to what I said earlier. The data challenges are some data is there, and it's fairly easy and straightforward to collect. For example, like manufacturing details and location, etc., and volumes. When it comes to other data points, for example, with carbon emissions and how do you calculate that, for example, there's a lot of gray area, and oftentimes you end up having some sort of an apple and pear comparison where it just doesn't make sense. One company's methodology might be slightly different than the others. So what is helping there is more standardization, and we see many efforts in the industry, also from like a governmental perspective, to standardize that, so we all have a shared common vocabulary. There's some good work also being done on the ISO level, but we're not there yet for all data points where we're talking apples and apples and actually can compare one company's reported information to the other.
Okay, thank you for the clarification. That makes sense. I think Brett is just typing there to maybe give some more information. Oh, there we go. So apologies. I think he's typing quite quickly, so maybe the question was unclear. So the question relates to how do you tackle having the risk you end up alone in the block? Do you end up alone in the blockchain? I think there might still be some queries around that question, but
yeah. I think the question is primarily around how do you make sure that so if one of your suppliers is a monopolist with low customer volume, so like how do you make sure that there's enough of a network, because the value is network based, and if you're on your own, like yeah, it doesn't make a lot of sense to kind of do something on your own. Like the thing that we see is that you don't need everybody to bring value, right? You definitely need more than one manufacturer and one company, but the first initial baby steps, if you will, of sustainability end-to-end is to be able to claim that a single thing or a single component or a single product is actually sustainable, not that the full product, including all of its subcomponents and every single raw material, because that is really far off. That is not something that is that companies can realize, specifically with more complex products, anytime soon. So what we see is that you can have a handful of companies, let's say 5 to 10, that can already bring a huge amount of value. Yeah, there is a risk of you being alone, and in that case, you're pretty bad off if you're the only one using a certain system like this. But you definitely don't need the full supply chain of thousands and thousands of companies to bring value, right? You can already have a huge amount of interesting data sharing capabilities and value to all parties if you start with a handful of companies.
Excellent, thank you. I'm sure, and I hope that has covered the question there for Brett. But if there are any other further questions, then obviously we will be sharing details with all of our attendees. So you're welcome to contact Circularise directly. Oh yes, he says thank you. So I think that's answered that. Just we'll wrap up now, but just Mesbah, from your point of view, if you just give a very quick final last comment on a question that I have, which is what role does this kind of software play then in helping manufacturers or manufacturing sectors even to work towards net zero? If you've just got a closing comment on that point, please.
Yeah, so we work primarily in the petrochemical space today. We do also have some less of a focus, but also some initial work that we work with minerals, metals, some fibers. So there's the core technology can be applied to any kind of material, right? There's no real restrictions there. The question is, where do you focus? And primarily our focus has been in moving away the petrochemical industry from fossil-based feedstock to bio and renewable and recycled materials. And parallel to that, as I said, we're also focusing on metals, minerals, some rare earth elements as well, but with a primary focus on the petrochemical space. There's a huge amount of potential there. Also, it's very much upstream, and these materials go into virtually any kind of end market, whether that's automotive or textiles or it's going to electronics or construction. This is all where these materials end up, and we need to make sure we have a good infrastructure in place to move away from fossil fuels.
That sounds like a very good closing comment. Thank you very much, Mesbah, for today, and thank you to everybody for joining. I hope you found the content and the conversation useful. It's been very engaging in the Q&A box. So like I say, any other questions you've still got for our speaker or for the Circularise team, there are some links further up in that chat box if you'd like to find out more about the MassBalancer, and also there'll be some follow-up emails sent out so that you can fire any other questions to them and open the conversation there. Thank you very much. You'll also find out more about the upcoming SIM webinars as we gear up for SIM Europe next year, which is taking place in Maastricht on the 25th to 26th of April. So there is also a link in the chat box there for anybody who's interested to join us. And we will be back on the 6th of December at 2 p.m. UK time for the final webinar in this series, which will be hosted by Alsnax Energy, and we'll look at revisiting power purchase agreements. So this is a focus on unpacking the uncertainties, opportunities and challenges for the industrial manufacturing sector in the current landscape. But for now, thank you again to our speaker and to everyone for joining today, and I hope you have a good rest of the day.